Hello and welcome to NestKing. Today we will be looking at a new tutorial about how to design a glass fiber nose section of a small aeroplane, also named radome. This is the part, the draft part that we designed for this purpose. This should be a glass fiber component, about 4 layers, in total up to 4 millimeters thickness, all over. And it is intended to be the nose section of a small airplane, either housing the weather radar, therefore we call it a radome, or it can also be housing any electronics. The front section should be as homogeneous as possible to enable the radar waves to pass through without any attenuation. And the remaining parts should be segmented into logical plies to enable easy and good molding during the manufacturing process. I have color coded different plies here. So we will have the green one, nose ply, which of course, when unwrapped and flattened, need to be cut radially here. Then we have on the bottom side one ply from left to right, and on the upper side 2 plies, blue and light blue. Of course, the blue and light blue could be easily combined to one, but for the sake of this video, I chose to segment them into 2 separate plies. These reinforcing ears on both sides, they serve the purpose of attachment. So we can attach this to either a hinge or another structure that will hold the entire nose cone. And they could also be easily attached to the blue plies, but again, for the demonstration of this video, we chose to have them molded separately as a ply. On the inner side, everything is homogeneous, and we have extra thickening plies at the corners to give the entire part a bit more stiffness near the mechanical interface. Great, let's go to NestKing. When you unfold your plies, this is what you get. In NestKing, the first step is to do the cleanup and delete unneeded geometry. Therefore, we enter the Sketcher environment and simply select and delete what is not needed. Now you can leave the Sketcher for a moment to continue with the second step, which is optimization. All your draft plies, they are segmented or faceted from many small lines, and this is not very handy when working with your geometry. Therefore, we have a function called optimizer. This optimizer needs a tolerance, 0.1 millimeters is well enough, and it automatically finds the outer and also inner geometry. The inner geometry is assigned to a different layer, shown by the difference in color, and it creates your outer and inner surfaces, or sorry, connects all the curves to a solid spline and reduces the number of interface points. This is a good feature for later cutting on a CNC machine. It prevents oscillations and even increases the speed of cutting. Good. Third step is to arrange my geometry in a good working fashion. Therefore, I will take these two and move them here, and I will also perform a rotation around this point, like that. Next thing, I will move the reinforcement ply just above here. That's enough. Now you see that we have only one of the blue plies, so I will mirror this to the right side by marking it, choosing the mirror object function, and then selecting an axis. And we are done. Well, with this arranged, we can just press on save and create the master cuts. Now, create the master cuts. It all changes color. By entering the sketcher again, we are going to assign the color that we used in our 3D model. So the centerpiece will be green. You enter this menu by double clicking on your master cut and then select the color. The bottom part had this brown green color. The same color was also used for the reinforcement ears. Here we had the dark blue. And on this one, we will use the light blue color. Good. These are our master cuts. The next step is to create the master table, which you find here, open master table. Now we have just one layer. I mentioned in the beginning, we want to have 4 layers all over the part, plus the reinforcing layers. So you can either copy paste or just add further layers until you have 4. Now I will change the material by marking all of them, then right click, modify, and then go to material. I will choose the one that I created before, 245. I will use the twill, 630 grams per square meter twill, and it is a glass fabric. Okay. Then angular arrangement. I will rotate the one in the middle by 45 degrees, plus and minus. And I will keep the top and bottom 0-degree orientation. It will not make much difference structurally here. The next thing that we can do is assign rotangs. These are the rotations that are allowed during nesting later on. So one ply should of course maintain the fiber orientation, but you can still rotate it in instances of 90 degrees. For example, it will maintain the fiber orientation, but it will give you more liberty when doing the nesting. Therefore, I will mark them as well, say modify, apply rotangs, and enter D90, which stands for delta or difference 90. Say yes, and it automatically adjusts the rotangs. And we are all set. So the next step is done. And now with this, we have to go again into the sketcher and start assigning edges that we know that they are in contact or interfacing, and managing the overlaps. Because what you do not want is when you connect all your plies, you don't want to connect them just face to face. You want there some overlap. You want to manage this overlap throughout your stack. And mainly you don't want these overlaps to occur at the very same spot. For instance, here, when we wrap the green part around the mold, these 2 points, they will come together and this line will close, but it will still remain as a cut in your stack, and you don't want this cut, this slice, to be on top of each other from one layer to the next one. So let's manage the first part, the green one. Double click on it. We need to find segments. So I will split segments. I will use the split segment and split the outer curve into 3. So this segment and then the 2 ones here. Okay. Now when I hover with my mouse, I can highlight the outer curve and then the 2 inner ones. Now the next thing is to use the linker, link them together, then move the link sign to a more comfortable area. And by double clicking on it, you can enter the management, the link management dialog. In the dialog, you see a couple controls here, and then a visualization of what you are doing. Let's start with the controls. So auto mode is fine. I don't want to overlap the first layer. I want an offset of 10 millimeters in direction of segment 1. Here you can choose both segments. This will do something called interleaving, so it will extend the first segment, then the second, and so on. And by hovering on top of this, you see where your cut is being moved. So this is now shifted to the right. The next one is in the middle. Then we have one on the left and one further on the left. So you will never have your slice on top of each other in your stack with the both section. Now, I like the both setting for this particular part, but for visualization, I will use segment 1. Anyway, you can change this later on anytime. Next thing you can see here is this visualization window. By double clicking on it, you can enlarge it. And you see that there are these wrinkles and there's this 90-degree angle that is being simulated. In our case, we do not have a 90-degree interface. There is no corner. When we look at the JT, we are here simply connecting the imaginary line here in the middle, and there is a 180-degree connection. Therefore, we should change this to 180 degrees. But before we do so, I would like to show you the effects of material thickness compensation, which is here. If you click on it, it will automatically adjust the material size. So it will adjust the offsets here by here minus 0.63 millimeters up to minus 3.78 millimeters to compensate the extra thickness that is created by the corner. Now, when you change this to 180 degrees, which is our case, we see that the material thickness compensation is zeroed out because it's not needed, right? So we can remove this, everything is back to normal, and we can continue. Here we did our first link. Now I would like to show what I'm doing. Therefore, I'm going to calculate the raw cuts or generate raw cuts. Yes. And now I will always see what the linker is doing. Now this, what we did here, should be replicated throughout the path for every other slice. Therefore, we should again follow the steps: segment, the curves, add link, and so on. This is quite a lot of work. We have a workaround. Double click on it, go to auto split, choose the section to auto split, and it gives you a split point on every corner that fulfills the condition now 80 degrees. So when I move along here and this has a difference of more than 80 degrees, it would split. Here it didn't do. Never mind. We'll use the split segment and assign a few points here. And now check. Everything was split into segments. Fine. Now, before you start adding an extra link and so on, I would like you to pay attention to the equalizer tool. I mark the equalizer, select this as master, and actually I want always the left side of our VDART to be the master. So I will mark the left side of every VDART, and it will simply copy the conditions that I have defined in the beginning. Press enter and escape. Now I will do the same for the right side of the VDART. Here, 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 and every other one as well. Voila. And now it adjusted everything else. And it actually worked fine. So this one is always extending, this one is retreating, extending, retreating, works fine. So the center part is actually done. Now, the next thing that you want to do, you want to continue connecting to your next ply. So let's do the connection to the blue one here. We know that the blue one, this edge is actually attaching to like not a half cone, but a quarter of the full circle here. So it is attaching to this line and this line. Therefore, double click here. I will auto split. Perfect. Nice. And I will create a linker from here to there. Now enter the link and check. I like what I see, but I will change this to 180 degrees. And I would like to go into direction 2. So the blue one should be shortened and the green one will be extended. And I'm happy with what I see. Fine. Now, again, I will use the equalizer to, first I will equalize the blue ones because this part should behave the same like this one. For that I forgot one point. I need to segment this first, auto split. Fine. And then link this. On the green part, I want to add a linker from this one to essentially all 4 of them that connect to the blue plies. So this goes out and the other 2 follow, and these are retracted. Now I can continue the same characteristics of this linker on the bottom as well. First split. And now what I can do, I can either use this will automatically select the master and it identifies which is following. So I want this to be transferred to the bottom section as well. And you can again take the linker, mark this. This one is now linked only to the other dark blue section, but I want this to follow as well. So great. Now to continue, we know again that the blue part here must be interfacing with the brown part here. Let's take a look. So we are talking now about this interface, right? For that, everything is already split. I will simply create a link from here to here. The link is by default the same as the others. We can take a look. Set this to 180 degrees. 10 millimeter offset in segment 1. Fine for me. Okay. And I will use the link tool again. This is my master. This should be the slave. And here is the master and this is the slave. So this worked rather well so far. I will save my work. And yeah, okay, I have created it before. That is why it is asking me to replace it. I'm okay with this. So this looks good. We also need a link here. We could either choose to use one of the masters and slave conditions from other links to reproduce on this one. But actually here in the middle, I would like a change. I would like to offset in both directions just to remain balanced. And I will go for both. It doesn't matter if I change this 180 degrees here because it doesn't influence anything. It's just a visualization. It would have an influence if I had used the material thickness compensation. Good. And now we are in the tricky part. Now what we want is to add these two together. And we know that the edge here, let's split this first, auto split, select, it did the 2 points I wanted, fine. We know that this edge here is not equally long like this one. I know that this point finishes here. We can measure that out in 3D. For that, I need to enable the measurement, take a single point, and I want to measure actually the edge here, 124.5 millimeters from that corner here, and then there is the blue ear. It begins exactly there. Okay. So I need to split this edge here. For that, I'm going to enter the master cut and modify master cut. And to modify master cut, I need to enter a point on a certain distance from here. Can use the point operator, offset point on geometry, dialog based. So start point, select. This is my starting point, but on this curve, that's the direction, fine. Distance, 124.5. Okay, it placed the point where I want it. Fine. Now I have to split the edge by the point. Break geometry by this point. Now it is broken into two, and I will be able to add a splitting point in the master cut tool. Exit sketcher. Now it is asking me to link characteristics. So this one, no, actually, yeah, this one can follow this lead. Actually, no. I didn't assign any characteristics to the edge. That's why this step is not so important. Yes. It even gave me an extra segment. That's nice. Okay. So we can now continue and redo what we did on the dark blue part, also on the light blue. Apply by double clicking on it, going to modify master cut, and then essentially repeating what we did before. Change direction, 124, it remembered even the value. Okay. And I did not split, that's why there was no identification. So break geometry, this one on this point. Now it did the break, and yeah, fine. Okay. Split segment is added. Continue. Now I can do the assignment between the ear and the newly created edge. And I want this, of course, to go in the other direction, segment 2. And here is what I wanted to show you. You see what happens? This is not nice, but we have a function for that. Everything else is okay. Here now, of course, it extended now the edge here almost infinitely because of this rather unlikely infinite connection. Double click on the corner, go to corner style, right click, and open connection point dialog. Don't direction one, just straight point to point will do. Okay. And we are going to do the same on this point as well. So what we did here on this point by double clicking and setting it to point, of course needs to be done here as well. But here I have noticed that there are now 2 points, so we need to manage that. I'm going to merge segments. Okay. This one with that one. No. So this one works fine. Here, double clicking, point dialog, point to point. Okay. And no shift points. Yes. No. Now there was some numeric error on this sharp corner from the 3D design, but we managed to solve it. And one of the last steps before we treat our reinforcement plies and go to nesting, and the final output is again to link this as master to here. And we are actually all good. Now, what is missing? This ear is only one part, but we have it on the other side as well. So we need to duplicate it. Duplicate our reinforcement or this structural ear here on the other side. You could either model or take this, copy paste, and then link and so on. Would also work, but it's much easier just to double click and say you want to mirror all of them, and it will automatically create a duplicate of this, which is mirrored. You could also increase the quantity if you had more of these and they were same, also from the orientation, then you could duplicate them and have it either mirrored or just simply duplicated. Fine. And the last thing that we want is this to be multiplied by a number of 4. We want to have an extra, we want extra 4 plies. We can use the ply packs for that. For these ply packs, we will deactivate the standard master cut. So we will exclude this ply from the 4 layers by removing this checkbox. And we will instead create a ply pack. I will create a ply pack with the 0, 90-degree orientation. Okay. And as next step, increase the size of it. I will go 1, 2, 3. So it will create a stack of 4. And now they lie on top of each other. What I would like to have here an offset of plus 5, or let's say plus 10 millimeters. Then in the middle, we can go to 0 in the second one, then here minus 5, and here minus 10. Now, I have created a pyramid like this. We can of course change this to minus 7 to make it look more equal, and then here minus 12. I can go minus 14, 15. Yeah, works well. And I will again mirror this. I want this to be mirrored, so I have 2 stacks, one on the left and one on the right side. And we are done. So now this is everything you need to do to create your ply stack for this component. Fun final look if we forgot anything. No, all looks solid to me. So we can save and leave the sketcher. And next and last final step is to create the nested output. And therefore we are going to generate master cut output. Here you see your master cut. So we have 4 layers. We have 1, 2, 3, and 4. And here on the bottom we have the ply packs. You see? And they of course will be mirrored. That's why you have here this mirror sign. Same mirror sign will appear also on this one. Let's look at the step number 1. It gives you the label, the raw tanks, the orientation, and the material. And we said that we don't want to overlap the first layer. That's why you don't see any offsets on the first one. On the second step, you can already see that the black is the original and the red is the outer or most outer or new, the cut curve actually. So this one extended by 10 millimeters here, this one retracted by 10. And you see what happened here. It's fine. Since we are using an offset of 10, the next numbers here on the third step should be 20 minus 20. And you see it works fine. So here you can check whether you have all the offsets right. Now the orientation, this is now a 0 and 90-degree orientation. The 45-degree and everything, this will be shown to you in what we are going to do next. And this is the nested output. To do that, go to auto nesting. The settings, we will not comment them for this video. There will be a dedicated video only on the nesting tools, nest all. And here you have a few things that you can tailor. What I will skip the nested lang, so I have an infinite roll of my material, and the cycles, I don't need 120 cycles. It's fine to use just 10 or 20 cycles. Gap 3 millimeters is fine. And we have used the raw tanks in the material definition in the master table. Here you can choose from different modi for the nest mode, but this is far too complex and out of the scope of this tutorial. Therefore, I will just call it nest to generate the nested output. Here on top, you see the runs it takes. So it is now the second run, third run, and it converged already quite well. And this is only for one part. Of course, you could have a nested output for multiple parts of the same one by simply changing the quantity of every step. You can increase the quantity and then you can nest 10 of these radomes. Nesting finished, and you can watch the report here. Report. Now this is empty because I still need to upload one extra block to generate reports, but this we will show you in a different video. Now have fun using NestKing, and please, if you visit our homepage, you can download NestKing for a 90-day free trial. If you have any questions, do not hesitate to fill in the contact form, and I will be in contact with you shortly.